We had sort of like one example left over at the end last time. I thought maybe we could do some variations on that last one. So I want a grammar, this is what I wrote last time, for just sort of like strings that look like long numbers. You know, for instance, my favorite long number, 8675309, right? Just a string that consists of a bunch of digits, one after another, right? How would I make a grammar for that? This is very simple. It's basically you want one or more digits, one after another. I would say something like, here's a little hint. You know, I'm going to have S goes to something, right? But I'm going to use something that I'll call D, goes to 0, 1, 2, etc. to 9. You can write them all out if you want. I mean, technically, ... is not supposed to be part of a grammar, but I think you all know what I mean, rather than writing down all 10 digits. All right, so I'll just use the D as a symbol which indicates a single digit. Anybody want to say? I think the rest you can just fill in right here. I want to just be able to make, you know, a whole bunch of digits one after another. Anyone got a suggestion what we can say here? Yeah? DS, yeah. I think I like this. I think there should be, this is great. So DS meaning you put one digit, and then if you want, you can put some more after it, right? That's why there has to be another S here. Don't just say D because you can only do that once. Like putting another S here allows you to go through this thing as many times as you want. There should be something which lets you stop. Actually, as is, this will never terminate because you can only do this one over and over again. The typical way to do that is to say or epsilon here. Although I'm not sure, do I really want to allow the empty string here? Maybe I'll just say or D. So this will not allow the empty string. It will allow a single digit by itself, though. Right? Great. So this grammar makes any kind of big, long thing. I have some simple variations that I would like for you all to think about. Maybe we can just start right off with you guys trying some. I hope you'll talk to your friends. I see a few of you have some. You can talk to people who are not your friends also. How about, okay, so variations. I have variation number 1, and that is disallow 0 on the front. When we typically write like numbers ordinarily, you don't put zeros on the left end of your number, right? So can we modify, like this grammar actually is able to generate things like, I could go S goes to 0S goes to 0S, I meant 00S goes to 004, right? Something like that. But let's say we want to, so that is allowed with this grammar. Let's say I want a variation of that which will disallow something like that. So that's one thing. Also, let me just say disallow 0 on the front, I will say except for just 0. So I want to, you should be allowed to just make a 0 all by itself, but otherwise you can't have anything which has a 0 on the left end, right? Okay, how about, so that's sort of one thing to think about. And then if that's not good enough for you, here's another variation. Allow a decimal point, and then if there's a decimal point, then no 0 on the right side. Right. If there's a decimal point, then you shouldn't put a 0 at the very end, right? Because that's sort of redundant. And then I got one last thing, which is, and you can do this, maybe this one, don't do it with a decimal point also, but commas. I know in math we almost never do this, but I'm talking about something like, 8675309. You put the commas in like that, right? Everybody knows how the commas go, right? See if you can make a grammar which also puts the commas in the right place. Now, it's not good enough to just insert commas like wherever you like in between 2 digits. No, the commas have to go specifically between groupings of 3 digits, except for the one all the way on the left, which doesn't have to have 3. It's a little complicated. So see what you think. I'll give you a few moments, and these are all going to be variations on what you see at the top there, but they are a bit more complicated. Here's a little hint for the first one. I don't know if you've gotten anywhere yet, but there's a lot of ways to do this, but this is my idea for, you want sort of two different symbols. One meaning this is a number which is not allowed to be 0. This is a number which can be 0 or one of the other ordinary numbers. Because you need to make some kind of distinction about the number on the left is not allowed to be 0, but all the other ones are allowed to be zeros. That's my suggestion.
Yeah, so this is what I had. Say D is like that. This is what I call, well, I call that C. Make another symbol, which could be in millions, but also 0. Good. Okay. And then separate that all out. You could write something like CT. Of course, C will be 0. Okay. But that's fine. It seems like the only way to get a decimal point is if it starts with 0 and then a decimal. Okay. You probably want to also something for EX dot something like that. Okay. Maybe that's good enough. How are you doing? Getting anywhere? start with S. So I would say S goes to C, and then maybe yeah, so I would say, like, the traditional way we do it is like S goes to CS. Yeah, you can do it over and over, but then that means it's at the ball, the next ones they all have to be C, which is not what you want the first one to be C. Okay. And the next one's to be D. Yeah, so I would say something like S goes to CT, and then T goes to D. You only do this one once, and then so that was
All right, here. I think actually this line probably even don't need that, because C, D and C are the same, it's just that D could be 0. So here you're saying any number that might be 0, here you're saying just any number that's not 0. But they're kind of yeah, because if you want to make, if you use a D, then you can turn it into a C. Yeah, great. Doing all right? Maybe we can talk about these. I know not everybody's done, but I don't want to. We could spend all day about these. The first one, people seemed to get started on at least. These are all a little tricky, and this is a kind of thing that, like, you have to kind of practice writing grammars for things. It's something that you can get a hang for, just like ordinary programming. Anyway, to disallow 0 on the front, the way I would have done this is something like S goes to CT, and then T goes to DT, or epsilon, or D. Probably epsilon is good enough here, although I think D is probably not wrong. Something like that. So I used 2 different letters here, the S and the T. The reason that I do that is because this one can just sort of, you can loop this one forever. And so you can make the number super long. And I'm using D here, which D is allowed to be anything, 0 or 1 through 9. This step can only happen once, though. So this is how you achieve this sort of thing where the first letter, or the first number, the first digit that you see is restricted, right? The first one you see has to be a C, but then the further ones, if you're doing more digits, they can be anything. And I'm not sure, as written, I think this cannot just make 0 all by itself, and that has to be included as a special case, so I would just put it like that. So if you want to make just 0, I think that's the only way that you can make just 0. And then any other number, you go through all of this business here. Any questions about that? I saw there were some people who wrote correct things that looked different from this, so there are different ways that you could do it, but to me, that's the way that I would have come up with. All right. How about also a decimal point? So if you allow also a decimal point, I think this can be modified. The decimal point is going to be sort of optional. So here's my answer with the decimal point. You know, as is, this can get any of the numbers like we said before, but I also want to allow numbers which have a decimal point. So I would maybe put something like, maybe in here you could add something like, or dot, well, this is not exactly right, but something like that will make it so that, you know, you do this one a bunch of times to create a bunch of digits before the decimal point, and then at some point you decide to put the decimal point, and then you have more digits after that, right? Now this is not quite going to work because if I use t here the same way, I could actually loop through this one several times and make like more than one decimal point. You could make many decimal points, and I don't want that to happen. So the way to make it so that really you only want to do this production once and not repeating it. And the way to do that is create another new letter. So I'm going to call this something like R here. And now R can be a bunch more digits after the decimal point. And the digits after the decimal point must not end with a 0. And so I would say this is yet a little bit more convoluted, and I don't know if it's possible to do this in a simpler way, but what comes after R? W maybe? WC, and then W goes to DW or epsilon. So this is just like, remember this S goes to CT. It makes it so that the first character is not a 0. I do the same trick here, only this time I'm putting C on the end, which means that the last character is not a 0. And then this will produce more digits. These digits will be to the right of the decimal point, but not the lastmost character. Something like that. Once they get kind of complicated like this, it becomes increasingly harder to tell if this is really correct, but I think this is correct. Anybody feel like I'm tripping here?
I think it's right, but what about 0 dot something?
0 dot something. Okay, this is good to think about. Yeah, I think I agree. This cannot produce 0 dot something, so I would do something like that. There's a lot of ways you could fix that, but yeah, thank you for that. I was tripping, all right? I still remain not 100% convinced that this is correct, but this is pretty close at least, all right? These are a little tricky to get to. Okay, can we try the commas thing? The commas thing, let's do the commas thing, but without the decimal point, just because I don't want to deal with all that other stuff. So let's try with commas. For this, you want the digits to appear in blocks of 3 digits at a time, except for the leftmost block, which could have only 2 or 1 digit in it. This is the idea. So I would say something like maybe, sorry, I gotta start with S. The leftmost block can have 3, 2, or 1 digits. So maybe I would say something like CDD. I'm gonna put it. Let's put a T here. CDD or CD or CT. Those represent the blocks of either 3, 2, or 1 digits, and I'm using C's and D's both because in those blocks you're not supposed to have a 0 on the leftmost piece of it. I think I'm feeling good about this so far. And then the T, what does the T become? So this is if I have a few blocks or a few digits. This T is going to generate a comma, first of all, and then followed by another block that looks similar. So it'll say something like comma DDDT or DD, no, I think just that. Or epsilon. I think maybe that does it. Any thoughts about this? Sorry, I sort of had this idea as I was walking over to class, and I didn't write down my answer ahead of time, so I'm not entirely convinced, but I think this looks pretty good. Maybe I'll just try. Can we derive 8, 6, 7, 5, I got the commas wrong. It should be here, right? No. Like this, right? Can I derive that? So I would start with S. And apparently this number has only one digit to the left of the first comma, so I'm going to go S goes to CT. That's the one digit. All right. Oh, and of course I didn't include, you have to have the definition of C and T and D as before. But, all right, and then the C can become my 8, right? So it's going to say 8T. And then 8T, the T becomes comma DDDT. So this looks like 8 comma DDDT. And then those D's become my next 3 digits, 6, 7, and 5. So 8 comma 6, 7, 5, T. And then that T again becomes a comma DDD. 8 comma 6, 7, 5 comma DDDT. And then finally those 3 D's become 309 and the final T becomes epsilon and I'm done. I feel pretty good about that. I think this is at least almost entirely correct. Any thoughts about it? All right, great. Grammars, they can do a lot. I believe actually this is a regular language, so you could have done this by making an NFA and then converting to a grammar. Although I don't think that's easier in this case. I have a hard time. I don't know. Actually, I didn't try to make an NFA for that, but it's not so complicated this way. All right. Excellent. This is all about writing context-free grammars for various languages. I had a couple more examples that are a little bit more complicated, just to give you a feel for how difficult these can be. There are some that are like very non-obvious how to write grammars for them. So I wanted to do just a couple of sort of interesting hard ones. How about X in A, B star such that the number of A's equals the number of B's? This looks kind of similar to ones that we talked about last time, but it's quite different. And the difference is like the orderings, right? So last time, the standard example you should always have in mind is the example for A to the N, B to the N. And the grammar for that is S goes to A, S, B, or epsilon, right? The number of A's is equal to the number of B's. Can anybody say, like, what's the difference between what I said here versus this language, A to the N, B to the N? They're not the same, and A to the N, B to the N is much easier. What's different about this one? Yeah?
A to the N, B to the N makes all the A's in the front.
Yeah.
The other one I can do it.
Yeah, these ones, they could be in any order at all, right? So you could have, it could be in any order. Whereas this one always has the A's at the front and all the B's at the end, which is why this works. This creates A's at the front and B's at the end. All right. So instead of this, you need rules which are perhaps going to create A's at the front and B's at the end, or also maybe B's at the front and A's at the end, or some mixture of that. And you may think, so I'm going to write this in red because this is not right, but it is tempting to imagine that this could be the answer, right? That just says you don't always have to put the A on the front. Sometimes you can put the B on the front. They still have to be balanced, though. Of course, if you want the number of A's to equal the number of B's, then you want your grammar to produce A's and B's at the same time so that they always have equal numbers. There is still a problem with this, though. If you think about all the strings that you can create with this, you will notice if you're only using these two rules, then every string you ever make, it always has the property that the first letter is different from the last letter, right? Either you did this rule first, in which case you start with A and end with B, or you did this rule first, in which case you start with B and end with A. That means this cannot generate something like, you can't get something like A, B, B, A, which this is part of the language I'm trying to do because it has two A's and two B's, right? But that string is not is not producible by that grammar there. Anyone got some idea how we could fix this up? Yeah?
Can you just do like ABSBA or BASAB? Add that on.
Okay. I think this actually might work. Sorry, definitely not that. What'd you say?
ABSBA, so just like
ABSBA. Okay. And then in addition to the rules I had before then?
Yeah.
Okay, so ABSBA, also BASBA, BASAB? Is that what you said? Yeah, and also ASB, and also BSA, and also epsilon, of course. I don't know about that. For example, what if I want AA, BBAA? I think this, I think you can't make that from those rules. Yeah. I had a good feeling about that, but yeah, this is, I think the idea is you made it so that I could start with any two different letters, but if you want to start with two same letters, it's not clear. Yeah. Actually, this, you have to sort of use a novel strategy. I would say the easiest way to make this work doesn't really look like anything else that we've done. And that's what makes this example difficult. And this is sort of why I bring this up. Sometimes this is an example that feels very similar to this one, but actually to make it work with the context-free grammar, you have to do a sort of a weird trick which wouldn't typically come to mind. So for me, like this app, there are, of course, many ways that you could do this, but I think this is probably the easiest way, although I'm willing to be proven wrong. ASB or BSA, or here's the weird one, SS or epsilon. It turns out that this will work. SS, check it out. If I wanted to do, say, ABBA, the idea is these two rules still are only capable of making it so that the first letter is different from the last letter. But if I look at this string, I think of it as broken down into those two pieces. And then each of those pieces could be made by the first two rules. And so this, to derive this, I would go S goes to SS first. And then the first S, I make AB out of it. So I go ASB and then epsilon there. So that was just working. And now I have created the first half of this string. And then I still have an S left over here, which I can now use to create the second part of the string here. So then I go A, B, B, S, A, B, B, A. There you go, which is what I wanted. So the moral of the story is sometimes you have to use, I talked about a few sort of rule of thumb tricks about balancing and unions and concatenations. There are some examples where you just have to do something weird that doesn't neatly fall into those categories, unfortunately. All right. I got, two more examples, and then we'll talk about something else. We got time. How about, this is actually sort of a famous example and an example that is a favorite of computer scientists the world around. This is the language, this has a name, it's called, actually I don't know how to pronounce this because I'm not a real computer scientist. I can think of two ways to pronounce this and I don't like either of them, but this is somebody's name. This is called the Dyke, I think it's Dyke language. And it is just a language of two letters in the alphabet. The alphabet is, and those two letters are brackets. So the two characters, it's not A's and B's, it's left bracket and right bracket. And the language is all strings. And this language is also sometimes referred to as the language of balanced brackets. Balanced brackets, right? So this language, the Dyke language, or whatever you want to call it, like this is a valid string in the language. So this is in the language. Whereas something like this is not in the language. All right, so the language consists of all strings where the brackets actually match up in the way that they're supposed to. All right. Can we make a grammar for that? This, on its surface, to me at least, seems very complicated. In fact, if I ask you, like, as a human being, how can you tell that this is balanced properly, whereas this one isn't? Even that is not obvious how, like, I'm sure everybody can do that, but it's not, if I were to describe to a child what it means that this is balanced properly and how I can tell whether it is or is not, that's not really easy to explain at all. Like, if I were really trying to work this out, I would have to say something like, okay, these two guys go together, and then these two go together, but why did I choose these two next rather than this one? It's because I know what I'm doing, I guess. It's hard to explain exactly what is it that I'm doing. And then these two go together, and then finally these two go together, right? The way, in your mind at least, the way that you match them up is not at all clear. Like, you don't exactly do it left to right. I don't think you do it right to left either. You do it, I don't know how to do it. And how do you know the last one is not balanced? I mean, this is kind of a giveaway, right? But that's not always true, of course, of unbalanced ones. They may not have like a hanging out one over here. It's also, I should just say, it's not just as simple as there's the same number of lefts and rights, although it's necessary in order to be balanced that they have the same amount. But like this one here, I made it so that there are the same number of left and rights, even though they still are not balanced. So I would say this as a computational question. Like, can you look at one of these and tell me if it's valid or not? It's not. This is not obvious at all. Like, if I were writing, say, if you asked me to write a Python program to read this one letter at a time and tell me if it's balanced or not, I wouldn't exactly know how to do that. I mean, you probably could. It's a complicated problem, right? That's all I'm saying. But check it out. The grammar of this is very simple, actually. That's why I want to talk about it. It has a very simple grammar. All right, the idea is, if it's going to be balanced properly, then every left bracket has to have a corresponding right bracket, and they both have to be like around some other stuff, and the other stuff also has to be balanced properly. Here's the grammar. S can become bracket S like that. So what is allowed is, from where you start, you can wrap brackets around another thing. You are also, you see up there, you can tell, for instance, here is one sort of block of balanced brackets next to another one. So you are also allowed to put two blocks of things next to each other. So, oops, like so, S, S, and that's all, or epsilon. This actually is the grammar for this, what on its surface seems to be a very complicated language. It turns out that this is all you need. So for instance, to generate, let's try and generate that string that you see on the top of the screen there, this valid one here. Can we make this? I start with S. Maybe it's worthwhile to think about what is the structure in terms of these sort of blocks of things next to each other. I see one full block there and another full block there, all right? And then I have brackets on the very outside. So I'm going to first do S goes to S inside brackets. Those are the very outermost brackets. And then inside of those, we are going to end up with two separate blocks. So next I'll go S goes to SS. Each of these S's will eventually create one of these green blocks, right? And so to get the one on the left, I make the one on the left inside brackets again, like that, and then make that first S go to epsilon. All right, so far we have the outer brackets and also the first of those green blocks. And then the next one, you want two nested blocks inside. So this S, I'm going to go to S inside brackets and then do that one more time. Like so. And then make this S go to epsilon, and I think I'm done. There you go. Right? Very, very cute example, I think, of something that is kind of computationally complicated, but you can make a nice grammar for it. All right? Any thoughts about that? Great. We're going to be talking about this language in other contexts later on also. It's an important example. This is pretty much all I wanted to say about grammars. We're going to talk about grammars like every so often as we go on, but as far as like just talking about grammars for their own sake, we're kind of at the end of that. The next thing we have to talk about is a new type of machine. But I don't know if you computer science majors are frustrated with me that this class is fairly abstract. I thought we'd look at a little real-world grammar. People actually use grammars, like computer scientists use this type of grammar in very kind of nuts and bolts ways. For example, I thought it would be fun to look at the official grammar. The official grammar for Python, everybody's favorite programming language. When you create a new programming language, as you do, when people create programming languages, they have to say publicly sort of, this is what the language is. And in particular, this must include a very specific description of what kinds of things you are allowed to say in your code. For instance, a line of Python code, it has to have a certain structure to it. You can't just type whatever you want, right? It has to abide by the rules of the language. And the way in which these things are officially sort of published to the world is they are written as grammars, just like this. And there is, if you can find this fairly easily, there is an official grammar that describes the Python language, and this is true for like pretty much any programming language. You should be able to go somewhere and look up the official grammar. So if someone ever asks you, hey, am I allowed to do this or that in Python? Your answer may be like, I don't know. But there is somewhere an official answer, and it is described in terms of a grammar about what is allowable and what is not in a legal Python code. So I thought maybe we'd just take a look at it here. I'm going to try and get fancy here. I actually am not sure if I'll be able to. I don't remember how did I do this last time? I think, yeah, we just don't need to look at my recording. Okay, so this is a browser window. I hope it's big enough for you to see. The address up here is just, it's python.org, which is the official place where all of the Python stuff is. And here we have the full grammar specification. This is the full Python grammar. It says, derived directly from the grammar used to generate the CPython parser. So when you run your code through the compiler or the interpreter, first it checks to see if the code is valid. And how exactly does it check that? Somewhere inside, it is checking that your code actually abides by the grammar, this official grammar. And so I thought it might be fun to try and see, I want to see where in the grammar can we find a place where you define a Python function. Maybe just because I can't write on it at the same time. I hope everybody remembers the way to define specifically a function in Python. You say def, and then you say the name of your function, something like func, and then you put parentheses and the name of the variables for your function. So maybe vary, I don't know. If you want, you can put several variables, right? I'll put another one here. I'll call it x. And then you do that, and then you do a colon, And then in here, sort of indented, you put some more lines, right? But I want to see where in the grammar does it say this? Somewhere in the grammar, it should say you can make a definition, and your definition, if you make it, must look like that. So of course, nobody really has this memorized or anything like that, but there is somewhere. So just about the formatting, I hope everybody can see all right. They don't use the little arrow like we do, just because that's inconvenient to write, but this says statement, that is a non-terminal symbol, like the big S or a big T or something. The colon is what we would typically write as the arrow. And then this bar, it means the same thing that we mean with, like, it means or, all right? So somewhere in here, you can see, there's here, function def and function def raw. Let's look at function def raw. So this says, this is where it is. It says literally def. So you have to write def followed by a name, and that somewhere elsewhere in this file, it tells you what the name is allowed to be. But that's the name of the function, all right? And then you have this thing inside of brackets. So brackets in this document are used to represent optional stuff. And apparently I use Python a lot, but I'm not like a super Python wizard. Apparently you can put some stuff here, type parameters. I didn't even know how that works in Python. I don't know. It has to do with specifying the type of your function. But anyway, you put some optional stuff here, which apparently I did not put. And then you put a parentheses. That goes next, right? Then a list of parameters. These are optional because it is allowed in Python to write a function with no parameters in it. But all right, and then there's this optional thing with the arrow. This also is something that I'm not familiar with in Python, but apparently there's some other thing that you're allowed to put in. And then the colon, that's here, right? And then after the colon comes, I'm going to scroll here, another optional thing, and then block. That means some more stuff, right? And anything you can think of that is allowed in Python, it is described in this document exactly how it has to be structured, right? So you could ask, when I make a function in Python, everybody knows you can put several parameters in a list like this. Is it allowed to put my parameters in a list like this? The answer is no, because that doesn't obey exactly this rule here, right? The rule says it has to be one parentheses, then your parameters, then the other parentheses, then the colon. It's got to look like that. So this can be a fun thing. Look up your favorite programming language, look up the grammar, and see if you can sort of identify basic structures from the language in that way. Some people like to get sort of competitive about how big the grammar is. Like you could compare, say, the Python grammar to the Java grammar, for instance. I don't off the top of my head know which one is longer. This is quite long, right? And the fact that this is so long indicates to me that the Python language is fairly flexible. That is to say, there are a lot of different ways that you can say things in Python. There are other programming languages are super rigid, meaning there's basically only one or two things that you can say. It doesn't mean the language is less powerful, it just means, like, structurally speaking, its grammar is simpler. Anyway, there's a lot of stuff here, which I don't use most of this stuff, but you can see, like, near the top is augmented assignment, aug-assign. That's these things. I use the plus equal sometimes, you know what I'm saying? All right, I thought this was interesting. So for you computer science majors who wish that I talked more about real life programming, how you like me now? Any thoughts about that? I think it's interesting to look at this sort of stuff every so often. Of course, like, an ordinary programmer doesn't really have to think about this at all. Although at some level, every programmer needs to know basic questions about, like, what exactly am I allowed to put here? Like, instead of def, can I write defen for definition? I like to write defen. No, you can't, because it's not. The grammar says def. It has to be def. All right, excellent. We got 3 minutes on the clock. I was going to start talking about an entirely new type of machine. I think maybe we shouldn't get into that. You want to see my other favorite, one of my other favorite languages? There's a programming language called Lisp. And one thing that people love about Lisp is that it has a very short grammar. This is the entire grammar for Lisp. Basically, Lisp only uses spaces and parentheses as its structures. So to define things, you just use parentheses. You don't use an equal sign to make a definition. You just put the name of something and then a space and then the definition of what it is. Mathematicians like Lisp. I think like sort of industry type programmers don't typically use languages like this. But this was invented like in the 60s or something, I think, by mathematicians trying to be cute about things, which is why it's so sort of like minimalistic. Yeah. All right, maybe I'll leave it at that. We will start talking about a new machine next time, and we'll have our quiz as usual. See you Friday.